title is Two Fields Separated by a Common Language.
Hi, everyone. So I want to begin by saying, if any of what you're about to hear sounds like the ranting of a crazy old man, I want everyone to understand two things. First of all, it is, and second, it will be over in 10 minutes. Let me begin with a brief introduction here. I teach, my day job is being a data scientist, building neural networks and all that fun stuff. But at night I turn into a superhero known as the adjunct, who teaches intro stats, college algebra, sometimes developmental math courses at UMUC, University of Maryland University College. And actually, I did want to touch on a point. It's a huge number of my students are either current or former military, so maybe I should use some of those bomb-dropping problems to see if we could make a better connection there and show practical applications. One of the things that has bothered me about teaching, and I've been doing this for 7-8 years, something like that now, is this whole thing is, and I'm sure many of you are familiar with this if you have taught those intro level courses, it is the student who you say, "Hi, how are you doing?" And the first thing you hear from them is, "Hi, I'm afraid of mathematics," or "Mathematics has never been my friend," or "I was never very good at mathematics." They're all variants on these things. I think we've all heard all the various versions of it. And I hear that both in math and I hear that in statistics. And it leads me to wonder something, and I'm only at the beginning of this. This is really not ready for presentation, but we're here anyway. About how closely related is statistics to mathematics? And should students who are at least afraid of math, do they need to be afraid of statistics? I mean, can we at least kill one bird, if not two? So one of the things I did was I wanted to look at how math and statistics departments kind of lay out. I am in a department called the Department of Mathematics and Statistics at UMUC, or whatever it's called. It is Math and Statistics. I don't think we're actually a department. I think it's, who knows. So I took the AMS survey of Mathematics and Statistics departments. They cataloged 1,526 departments, and they grouped them by public, private, size, yada, 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 added some specialty departments. I just looked at the top large public and large private math departments. There are 26 large public, 24 large private. There were separately from that 56 statistics departments. These were not math departments, these were statistics departments. And then 30 that were applied mathematics. And then there were also 47 biostatistics departments. And then a bunch of these were statistics departments broken down into business schools, because that kind of gets taught separately in business schools and other places like that. We're going to kind of set those aside for now. Of those 56 statistics departments, 11 of the large private math departments, almost half, also had a stats department within that university. And then 18 of the large public, more than half, also had a separate stats department. And then we can see this here with applied mathematics, where we see 9 of the large private have applied, 5 of the large public have applied. So what we see is there's a differentiation, at least in these larger schools, where we have a separate statistics department, let's just say about half the time, maybe about 55%. So now I'm left wondering, does statistics actually need mathematics? Let's stop and talk about physics for a minute. Physics relies on calculus. Isaac Newton, the guy I've labeled up here as the master of the mint, needed to develop calculus to get through his physics problems. And if you've how many people here have taken physics? Like, college level physics? You had to do calculus in it, right? Could you even imagine an intro physics course for students that wasn't calculus based? I mean, they exist, but they're horrible. Nobody should take them. Physics departments are always grouped with natural sciences, right? I mean, it's with your, sometimes with chemistry, sometimes there's a separate astronomy department, all this other stuff. Actually, recently, I went to the University of Maryland for undergrad. They've recently actually taken all of the natural sciences, math and computer science, and merged them all into one department. But even then, it's separate from math. Physics and math are still separate. So I also have this other guy, history forgot. Anybody recognize the picture, or at least you can guess who he is? Just shout it out, I don't care. Yeah, there you go, right. Just making sure. So then we talk about statistics. Statistics relies on calculus, just like physics. Calculus-based statistics courses are, again, pretty standard, right? Not my statistics course, not the one I'm teaching. We barely have calculus courses, and it's not a requirement for almost anybody at UMBC. There are non-calculus statistics courses available, as I just said, but you don't want to take them. Nobody should take them. You walk away with only a light understanding of statistics. You can get the probability part, but you can't really get to things like what is a PDF. And these statistics departments here usually, well, at least half the time or so, part of the math department, especially when you get down to the smaller schools, right? When we had those big schools, you have about half, but that other, 30 stats departments that weren't included in the public-private list, that other 30 is dispersed among 1,500 universities. Now, I do want to say right here that, first of all, it's very hard to only pick 2 statisticians. When I put up this picture of Bayes, I was going to put up here the title, "This is probably Bayes," right? Except here's a problem. We actually don't know who this is, and we actually only think it's Bayes. So it turns out the title's appropriate. And then, of course, I'm blanking on the second guy's name right now. Thank you. So anyway, just hard to pick statistician pictures here, right? Because how many statisticians are there who founded the field versus, say, calculus? So now I want to know, is statistics different? This gets us into the question of formal science versus natural science. A formal science we're all very familiar with in in mathematics. Because in mathematics, what we do is we have a base set of rules. Think about, you go back to geometry, Euclidean geometry, let's make this easy, and say, there are 4 basic rules, right? And everything falls from there. In fact, it's kind of astounding. Everything comes out of those 4 basic rules. My recollection is there are 8 that get you to real analysis, and then you only add 2 more to get you have 8 to get analysis and 2 more to get real analysis, because you got to abolish imaginary numbers. But anyway, statistics works the same way. We actually have a bunch of axioms in statistics, which were drilled into me at some point as an undergrad, and I've now completely forgotten. But we go through and we prove things. These are not, we think this is usually true. We prove it. And as mathematicians, we're the only people on earth who can be absolutely convinced of the truth of something, right? Everyone else, you best get a probably. Then you have physics, which is a natural science. Now, physics, like economics, really wants to be a formal science. They want to have those formal rules laid out where they can say, we know that this is always the case. But they're not getting there yet. And these natural sciences, like chemistry, biology, whatever, they're experimentally driven, right? They go through and say, I think this might be the case. Now let's see what happens. That's how that LIGO detected that's why LIGO was necessary to detect the black hole collision. Because we're like, well, we think this is going to happen, but we need to check. Mathematicians go, it'll happen. Don't even bother to check. So maybe statistics is different. But here's the thing I also catch. Computer science is also a formal science based on those formal rules. And it's always a different department for mathematics. I can't think of any department in the United States where you have a combined math and computer science department. So what I've learned is there are no good conclusions here. So what this means for teaching. As I said, many of my students come in and they're afraid of math and they're afraid of statistics. Math anxiety is commonly observed in students across demographic divides. I get male students, I get female students, I get young students, I get old students. I get it in students with work experience, I get in students that don't have work experience, I get in students that have had this math, I get in students that didn't have this math. And we also see this anxiety with statistics. Unlike other formal sciences, mathematics and statistics are a required part of general education requirements. Statistics is necessary requirement supporting many other fields, for instance, to drive social science, especially those that use statistical inference as part of their core methodology, as I said. Students are exposed to more math and statistics than other formal sciences. We never really see computer science pushed on students or system science. So maybe this anxiety surrounds thinking styles necessary in formal sciences. Maybe it's not the numbers. Can we ease math anxiety by introducing more logical concepts earlier? Can we start teaching these things like in the 3rd grade? I got a second grader at home, and I'm constantly drilling this into him, and he hates me for it. Will reduced anxiety, and then we want to know, will reduced anxiety support better assimilation of the material? Well, I think that's obvious, right? We know that. So that's that.